Hey everybody, in this video we're going to talk about Pascal's triangle, binomial coefficient, where we left off last time, and then we'll bring it into the binomial theorem and how it helps us expand binomials. Okay, so if you remember these binomial coefficients give us our Pascal's triangle, right? So why is this useful? Let's talk about the binomial theorem and how we can relate this to expanding binomial. For any binomial a plus b and the natural number n, so this is binomial, what we're going to do, we're going to raise that a plus b to the n power. It's equal to these coefficients, binomial coefficients, times our exponents, which we talked about in a previous video, right? We take our first term, we raise it to our highest power, and then we multiply it by our second term raised to the 0 power, and then we decrease the powers on a but increase the powers on b. And then this is going to be a row in Pascal's triangle, but we get those by doing n choose 0 or n choose 1, etc. We can also state this theorem in summation form, and it is that this binomial can be expanded by taking the sum of n choose r times a to the n minus r times b to the r. Now that might be a little bit confusing here, but remember summation notation. We start at r is 0, so we're going to do n choose 0 times a to the n minus 0 times b to the 0, etc. But then n is going to be chosen by what our power is on that binomial. So, can we use that binomial theorem to expand this? Well, our n value is 4. Okay. Our a, remember we have a plus b in the binomial theorem raised to the n. So our a is going to be 2x. Then our b value is going to be negative 3y. Why negative? Because I need to have a plus there. So I have a plus, a minus. Okay. So as we expand this, the binomial theorem says we're going to take 4, choose 0, and then a, 2x to the 4th power, plus 4, choose 1, times 2x to the 3rd power, and then b, or 3y to the 1 power. Now remember, right here, what do we have multiplied? We have negative 3y to the 0 power, but that's just 1. And we are adding, that looked like an arrow, we're adding. Then we're going to add 4 choose 2 times 2x squared, negative 3y squared, plus 4 choose 3 times 2x to the 1. So I'm reducing the powers on those ones, and I'm increasing the power on these ones. And then I'm going to have 4 choose 4 times a to the 0, so I'll just keep that as 1, times b to the 4th power. Okay, now 4 choose 0, we can do this on our calculator if we want, or we can use the formula that we talked about in the previous video, where if we want to write that out, n choose r is equal to n factorial over r factorial times n minus r factorial. After we do that, we'll get 4 choose 0 is 1, and then we'll get times 16x to the 4th, and then 4 choose 1 is 4, times 8x cubed times negative 3y plus 4 choose 2 is 6. Then we'll get times 4x squared times 9y squared. And we'll get plus 4. 4 choose 3 is 4. Times 2x times negative 3y cubed is negative 27y cubed. Then we'll get 4 choose 4 is 1 times 81y to the 4th. After some simplifying, we'll end up getting 16x to the 4th minus 96x cubed y plus 216x squared y squared minus 216x y cubed plus 81. So this is that binomial expanded all the way. But let's say that instead of expanding a binomial raised to an exponent, that we're told to just find one specific term. There's a formula for that. We'll talk about the binomial formula, binomial theorem for specific terms.